Hello, FOM 11 students. This is Trigonometry Lesson 9. It's called Selecting a Strategy. This is actually our last lesson in trigonometry, which means I will be sending you a unit test soon that you can do at home, open book, and then take pictures and send back to me. Excuse me. Okay, but before we get to that, we have this one final lesson to do. It's called Selecting a Strategy. I am going to call mine answer key. And it goes like this. Warm up. Now, excuse me, we have learned the 5 main tools of trigonometry. Let's list them and determine the pieces of information you need to know about a triangle in order to solve it. First of all, we started off with the Pythagorean theorem, which is c squared is equal to a squared plus b squared. You need two sides to solve for a third side. Okay, so for the Pythagorean theorem, you have to know 2 of the 3 sides, and then you use those 2 sides to solve for the third side. The second tool of trigonometry was the primary trig ratios. And for that we have an acronym, SOHCAHTOA. Stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. You need one side and one angle to solve for a side, or if you want to solve for an angle, you need 2 sides. Okay, so you need one side and one angle to solve for another side, or you could have 2 sides and then you can solve for an angle. And remember, guys, with the Pythagorean theorem and primary trig ratios, those are for 90-degree triangles. Okay, or we also call them right triangles. Okay, so I'm going to say for 90 degrees or right triangles. Okay, the third tool of trigonometry is angle sum of triangle. The 3 angles in a triangle add to 180 degrees. So angle 1 plus angle 2 plus angle 3 equals 180 degrees. You need 2 angles to solve for a third angle. Okay, and this property is true for any triangle. Okay, and then the fourth tool of trigonometry is the sine law, and that says that sine A divided by A is equal to sine B divided by B is equal to sine C divided by C. And so for this, you always need an angle and its opposite side. It's called an angle-side relationship. Okay, so you need 2 angles and 1 side to find a side. and two sides and one angle to find some other angle. Okay, and then of course from there was the cosine law, and the cosine law says a squared is equal to b squared plus c squared minus 2bc cos a. And for this, you need two sides and the angle in between those two sides. To solve for a side, or if you want to solve for an angle, you need all three sides. Or you need to have all three sides to solve for an angle. And remember, these two tools of trigonometry are for non-90-degree triangles. Okay, and so those are our tools of trigonometry in a nutshell. Okay, and then it says the following chart will help illustrate the thinking you'll need to do for each of the questions you'll do today. And so basically you have to ask yourself, hey, is the triangle a right triangle or not? Does it have a 90-degree angle in it or not? If it does have a 90-degree angle in it, we're talking about triangles that look like this, right? And it'll show you a 90-degree box. Okay, and so basically, as you can see, guys, with right triangles, it always ends up either being SOHCAHTOA or Pythagoras. And you can always use, if you know two of the three angles, you can always use angle sum of triangle. Okay, but that's kind of a key point there. So for right triangles, it's always going to be SOHCAHTOA or Pythagoras. And for non-right triangles, so very general triangles like this, for example, see how I don't have a 90-degree box, that always ends up being either cosine law or sine law. All right, so let's try a few examples. Example 1, for each of the following, solve for the indicated side or angle. And example 1 says, find the appropriate method and solve for the indicated sides or angles. And in letter A here, it wants us to find TU. Okay, and what we could do first, because we know two of the three angles, excuse me, my allergies are acting up. Let's get the third angle, 180 minus 66 minus 49. And we get that this angle over here is 65 degrees. Okay, so you can see, guys, that this first triangle is not a right triangle. There is no 90-degree angle. Okay, and when there's no 90-degree angle, that means we have to use the sine law or cosine law. Okay. And when you have an angle and its opposite side, that's a prime candidate for the sine law. Okay. And since it wants us to find TU, that's across from capital letter S, so they want us to find little s. And since we know capital T And little t here, we can use the sine law like this. It's sine of angle t divided by its opposite side is equal to sine of angle s divided by its opposite side. So we would get sine of 65 degrees divided by 10 is equal to sine of 66 degrees divided by s, and we have to solve this for s. Okay, so cross multiply and we will get s sine 65 degrees is equal to 10 sine 66 degrees. And then we would need to divide both sides by sine 65 degrees. Here's what we're going to get for s. 10 sine 66 divide by sine 65. Okay, so 10.1 millimeters. Okay. In letter B, they want us to find CD, and notice they're showing a 90-degree angle, and in a right triangle, we can either use Pythagoras possibly, or SOHCAHTOA. And we are trying to find this side CD, which we could label little letter b. And when you have two of the three sides, that's classic Pythagoras we could use. Across from the 90 degrees is the c, and this one we can label a. And just go a squared plus b squared equals c squared. A is 12, so I'm going to go 12 squared plus b squared is equal to 13 squared. And subtract 12 squared from both sides. And we end up with b squared equals 13 squared minus 12 squared, and we get 25. Square root with a plus or minus. B equals plus or minus 5. We're going to reject the negative answer. Therefore, B is equal to 5 centimeters. We're finding the length of a side of a triangle. All right, so that's how you do letter B, classic Pythagoras, in a 90-degree triangle. Letter C, find angle F. Okay, they're not showing a 90-degree box, and when they're not showing a 90-degree box, it is either sine law or cosine law. And sine law is only good if you have angle and opposite side, which we don't have any of the angles. Cosine law is good if you have all three sides or two sides and angle in between. Okay, we have all three sides, so we'll use the cosine law. They want us to get angle F, which is right here. And remember, when we use the cosine law, the angle that you know or you want to know, you relabel that as A. And then that will help us get the side labels. So that's little a, and that's the biggest thing we need to do. Then B and C can be anything you want. And remember, the formula for cos A, when you want to get the angle, is a squared minus b squared minus c squared, all divided by negative 2bc. So we are going to get 11 squared minus 8 squared minus 9 squared divided by negative 2 times 8 times 9. Okay, so cos A is equal to 11 squared minus 8 squared minus 9 squared divided by negative 2 times 8 times 9. And we get 0.166 and a bunch of stuff. And then to get angle A by itself, you do cos inverse of that side. So I am going to go shift cos, second function minus sine to put the word answer in there, and there's our angle, about 80 degrees, to the nearest degree. Okay, in part D, they want us to find angle X, and look at that, guys, a 90-degree triangle. So a 90-degree triangle means either Pythagoras or SOHCAHTOA. Pythagoras is only good when you want to find a side length. We want to find an angle, so we're going to have to use SOHCAHTOA. So we're looking for angle X. Straight across from it is the opposite side. Across from the 90 is the hypotenuse. So this must be the adjacent. So we're going to be working with opposite and adjacent. Opposite and adjacent. That comes from tan. So it's simply tan of angle X is equal to opposite over adjacent. And so X is tan inverse of 9 over 12. Shift tan of 9 divided by 12, and we get that angle X is about 37 degrees. Okay, so I'm going to put a little dot over the equal sign, meaning that that is approximate. Okay, so you can kind of see a mishmash of trig tools coming out here. Example 2, find all the missing angles in the following. Okay, so remember they're not showing a 90-degree box, so immediately that means either sine law or cosine law. And the sine law needs an angle and its opposite side. We don't have any angles, so that's no good. So it must be cosine law. We know all three sides. Excuse me. And so it's totally up to you which angle you want to find first. Maybe we could find angle R. And the angle that you want to find is called A in the cosine law. So that means this is little a, and then B and C don't matter. So cos A is A squared minus B squared minus C squared divided by negative 2BC. I would always give you that formula. Okay, it's just a slightly changed up version of the cosine law. So cos A is equal to 15 squared minus B is 17, so 17 squared minus C squared, C is 23, divided by negative 2 times 17 times 23. And in the calculator, I'm going to go like this. Put brackets around the top. 15 squared minus 17 squared minus 23 squared. Divide that by Negative 2 times 17 times 23. 0.758. And so A is equal to cos inverse of that 0.758 stuff. And we get about 41 degrees. Okay, so we now know that this angle right here is 41 degrees. And since I've relabeled the triangle as this as angle A, and I've got this side as being B, why don't I change the Q to angle B? And since this side is C, its friend angle over there is capital C, so we could do that. And so guys, now that we know one of the angles, we can now switch to using the sine law because we have an angle and its opposite side. So then we can get this angle using its opposite side there. All right, and so what you can do is say, hey, sine A divided by A is equal to sine B divided by B. So sine A is 41 degrees divided by little a is 15. Sine B, we are looking for that B, and little b is 17. And solve this for B. Okay, so you can start with cross multiplying and you get 17 sine 41 degrees equals 15 sine B. But then notice we're just going to divide the 15 back down. So we could have just left it there to begin with. So sine B is equal to all of that. 17 sine 41 divided by 15, 0.743. And so angle B is equal to sine inverse of all of this. So, excuse me, angle B is shift sine of that last answer, 48 degrees. Okay, so I'm just going to fix up my diagram here a little bit so it doesn't have so much stuff on it. We just figured out that this is 48 degrees. And the way to get angle C now, guys, this one here, is you can use angle sum of triangle. Angle C is equal to 180 degrees minus 41 degrees minus 48 degrees. Okay, because the angles in a triangle have to add to 180. So 180 minus 41 minus 48, and we get 91 degrees. And that is how you do example 2. And finally, we are on to example 3 before you see the assignment there. It says find the area of the following triangle. Area is equal to base times height divided by 2. The base is right here, so the base is 18. We have to figure out the height of the triangle and then do base times height divided by 2. Okay? So, it's going to be challenging to get the height of the triangle, though. Okay, because we know that this whole angle is 72. Here's our plan of attack, guys. If we can get this angle right here, then we could use SOHCAHTOA in this 90-degree triangle. See how that's 90 degrees? Then we could do like opposite over hypotenuse. So sine of whatever that angle is. Okay, so my plan is to try to get that angle in the bottom right corner. And we have a big non-90 degree triangle with an angle and its opposite side. So I'm going to label this B because I've labeled that little b. And maybe we can call this A and this side little a. So what we're going to have to do first, guys, is this. We are going to have to figure out angle A using the sine law, and then we will then know this angle, and we can do angle sum of triangle to get this angle, and then using that angle we will do SOHCAHTOA to get H, and then we will use area equals base times height divided by 2. Okay, so that's the plan of attack. So let's get angle A first, and I will say sine A divided by its opposite side is equal to sine B divided by its opposite side, because we know angle B and its opposite side. So sine A divided by its opposite side is 12, and sine B, angle B, is 72 degrees, and its opposite side is little b, which is 18. And to get sine A by itself, basically what you have to do is multiply both sides by 12. And we get sine A is equal to 12 sine 72 degrees over 18. And so sine A is 12 sine 72 divided by 18, and we get 0.634. So A is equal to sine inverse of 0.634. Okay, so angle A is shift sine of that answer, and we get about 39 degrees. Awesome, so this is 39 degrees. We know that B is 72 degrees, so angle C is equal to 180 degrees, take away 39 degrees, take away 72 degrees. 180, take away 39, take away 72, 69 degrees. Okay, so we now know that angle C is 69 degrees. And what we're going to do, guys, is we're going to work in this small little 90-degree triangle right here. And the side opposite the 69-degree angle is H, that's the opposite. And across from the 90 is the hypotenuse. Okay, and which trig ratio deals with opposite and hypotenuse? That would be sine. So I would go sine of 69 degrees is equal to H over 12, and multiply both sides by 12 to get H by itself. 12 sine 69, and we get 11.2. Okay, so the height of the triangle is 11.2 millimeters, and it says find the area of the following triangle. Area is equal to base times height divided by 2. So it's 18 times 11.2 divided by 2. 18 times 11.2 divided by 2, and we get 100.8. And the 18 was in millimeters and the 11.2 was in millimeters, so that's going to be millimeters squared. Alright, so there you go, guys. That is Trigonometry Lesson 9. That is our last lesson in this unit of trigonometry, which means I'll send you a test soon that you can do open book. In the meantime, check out this assignment, try all those questions, and as usual, there is an answer key at the end, I think. Yep, there's the answer key. And as usual, I will send you a video link showing the solutions to this homework a little bit later in the week. All right, take care, everyone. I will talk to you soon.